There are different types of chemical reactions, so let's take a look at them. Be able to define combination reaction, decomposition reaction, single replacement reaction, activity series, double replacement reaction, and combustion reaction. And you may have noticed I didn't just define them for you. That's because I'm going to be doing each one on a separate slide. And this is actually pretty darn nifty with the examples. It's kind of a fun topic. Be able to compare different types of reactions, be able to give examples, and of course, if given an example, be able to identify what type it is. Identify the reaction type by the balanced equation. Ooh, harkening back to 11.1. And be able to write the equations for different reaction types. So let's get going. A combination reaction is where more than one substance is going to combine into a single substance. So take, for example, burning magnesium. Magnesium, which is on this ribbon here, and oxygen in the atmosphere are going to combine to form magnesium oxide. So they combined to make a single thing. Often these combination reactions will give off heat. Not always, but pretty often. Now compare those to decomposition reactions. This is where one compound is going to break down into more than one compound. The formation of quicklime from limestone is one example of this. When limestone is heated up sufficiently, it creates quicklime and also creates carbon dioxide. Now it may be difficult to predict the outputs because if you were to consider, if you were to add, say, oxygen to this, then you might actually get more carbon dioxide and less quicklime and end up with, well, calcium. Or if you were burning charcoal, you can get carbon monoxide or carbon dioxide. So it's a little harder to get the outputs done. And often these decomposition reactions will take in heat, especially if they're turning something that is more stable into something that is less stable. Single replacement reactions. This is where one element replaces another in a compound. A good example of this is thermite. So thermite is when you have the iron in iron oxide, i.e. rust, being replaced by aluminum. If you put iron oxide and aluminum together and then you heat them up just a little bit, they start a single replacement reaction, which gives off liquid iron. Liquid iron is hot, and this is used in warfare as dragon drones. So these are going to give off the thermite reaction. Of course, the drone will be used up, and it will drop liquid iron onto a battlefield, resulting in fires, lots of fires. Also, it is a bad thing to be underneath one of these when it goes off because liquid iron landing on a person is, well, painful. So these are used for fear tactics. How do you predict what's going to replace what? Well, that's using something called the activity series. This is kind of cool. So you can actually predict which elements will replace others by listing them in order of decreasing reactivity. Now in class, or rather in lab, we added zinc to copper nitrate, and we got zinc nitrate and then copper coming out of the bottom. That's because zinc is above copper here. So you can see zinc up here and then copper down here. So if you have copper nitrate and you were to add, say, iron, then you would replace the copper with the iron. Now, that's going to be a little slower because they're closer. And the farther away is the more replaceable they are. So we see iron and aluminum are up here. They're going to replace one another. The aluminum is going to replace the iron in iron oxide. And energy is often given off when the replacement occurs. Now, double replacement reactions is when two compounds are going to exchange cations. So potassium iodide is a clear colorless solution, and lead nitrate is a clear colorless solution. But when they add them together, you're going to get this yellow stuff. That's lead iodide. Now, that's the potassium lost its iodide and the lead lost its nitrate, so they're going to replace there to get potassium iodide. Now, of course, you get potassium nitrate in the solution. So lead iodide and potassium nitrate. The potassium nitrate stays in solution. The lead iodide will come out as this golden color. Now, you can also see these as gases or solids getting produced as a solid, the precipitate there. The neutralization of acids is also a double replacement. So hydrochloric acid plus sodium hydroxide produces water and sodium chloride. And then it's combustion reaction. This is when you have an element or compound reacting with oxygen, usually causing fire. So that's kind of the definition of combustion. It's reacting with oxygen, often produces carbon dioxide and water, especially if you're burning things like hydrocarbons. And these are often used for giving off a fair amount of heat.